All right, today we're going to look at the perimeter and area of similar polygons. So let's make like Felix the cat and see what is inside our bag of tricks. Okay, got a couple of similar polygons here. They're triangles. In fact, they're right triangles. The scale factor, let's make sure we know what the scale factor is. Aha, it looks like if I have the large triangle and multiply everything by 1/2, I get the smaller triangle. So I'd say that k could be 1/2. Find the perimeter of each triangle. I'm going to do the small triangle first. 3 plus 4 plus 5 is 12. I don't see any labels, so I'm just going to put units. The larger triangle, triangle DEF, add the sides, I get 24. And if I look at the ratio of the perimeters, surprise, surprise, I get 1/2, which of course is identical to the scale factor of the triangles. So not only is the scale factor consistent for each pair of sides, it's also consistent with the perimeters. Right? If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. Okay, let's look at areas. Same two triangles. Move the picture around a little bit. They're still right triangles, by the way. They're the identical triangles. So we already knew that k was 1/2. Don't need to find that again. Area. Of course, area of a triangle is 1/2 base times height. Why is it so important that I said they're right triangles? Well, if they weren't right triangles, I wouldn't know for certain about the height. Right? If I wanted to declare that 4 is the base of triangle ABC, I have to have a right angle there to then declare that 3 is actually the height. Right? If I don't have a right angle, then 3 is not really the height, right? It's something else. So 1/2 times base times height, I get 6. Call it square units because there's no label for their triangle. And again, it's a right triangle, so we can use 6 as the height. 1/2 times base times height. And so 6 times 8 is 48. Half of 48 is 24. So that's 24 square units. Let's find the ratio of those two areas. And I get 1/4. That's not the same thing as 1/2. We got to do a little bit more investigating here. All right. Let's look at rectangles this time. Again, I know those are right angles because the directions say they are rectangles. Scale factor. Let's make sure they're really similar. 2 compares to 6 is 1/3. 5 compares to 15 is 1/3. Okay, they're the same. Scale factor is 1/3. So let's find the area. Well, length times width. For the smaller rectangle, 2 times 5 is 10. 10 square units. Larger rectangle, I got to do 6 times 15. That's 90, so 90 square units. Okay, let's find the ratio. 1/9. So when k was 1/2, the ratio of the areas was 1/4. When k is 1/3, the ratio of the areas is 1/9. What's happening? 1/2 times 1/2 is 1/4. 1/3 times 1/3 is 1/9. So the ratio of the areas is k squared, right? If I know scale factor k, I square it to find the scale factor for the areas. All right, if the polygons are similar, the ratio of the areas is equal to the squares of the ratios of their corresponding side lengths. So let's take a look at an example. Ooh, there's a trapezoid. And 12 equals feet. I gotta fix that. I'm not gonna fix it now on this recording, but I'll fix it for the slides. Scale factor is 2/3. So let's find the perimeter of the original trapezoid. Well, you just add up all the sides, piece of cake. Perimeter is 42 feet. What's the area? It's a trapezoid. I have to average the bases and then multiply by the height. So how do I average the bases? Well, I add them up, divide by 2. So the bases are 8 and 12. 8 plus 12, of course, adds up to 20. 20 divided by 2 is 10. Finally, 10 times 9 is 90. So the area is going to be 90 square feet. Okay, now, if we construct a second one where the scale factor is 2/3, I'm assuming we're going to multiply every number by 2/3, right? So that 13 would get multiplied by 2/3. The side that's 8 feet would be multiplied by 2/3. The side that's 9 feet would be multiplied by 2/3. And the side which should be labeled 12 feet would be multiplied by 2/3. So what happens with the perimeter and the area? Well, the perimeter of the new trapezoid, I take the previous perimeter, multiply it by 2/3. And again, I can turn 42 into a fraction. 42 is secretly 14 times 3. Cancel out those 3's. I get 28. So the perimeter of the new trapezoid would be 28 feet. Now for the area, again, the previous original one had an area of 90, but instead of multiplying by 2/3, I have to multiply by 2/3 squared. So I'm doing 90 times 2/3 times 2/3. Of course, 2 times 2 makes 4. 3 times 3 makes 9. So I've really got 90 times 4/9. I can make the 90 90 over 1 if I so desire. 90 is secretly 10 times 9. Cancel the 9's. And I come up with 40. The perimeter is 40 square feet. Now, if need be, I'm sure some of you have a calculator that would perform fractions for you. So you can do 90 times 2/3 times 2/3, and the calculator, if you push the buttons in the correct order, will say 40. All right, if you want to do it by hand, step by step, that's cool. I usually do it both ways, right? If I want to use a calculator, I will then check by hand, or if I do it by hand, I'll often use a calculator just to double check and make sure that I was going on correctly. So we're going to have a really awesome little worksheet to work on. And then besides the worksheet, there's also a nice little IXL that we can work on. Oh, come on, can we read that? Ah, there we go. Now we can read it. And that wraps it up.